Good morning. My name is John McGowan and I'm the chairman for this session. I also am a director of CITA. For my sins, I obviously committed some grave errors in the past and I'm now being punished for it. But however, more seriously, it is my privilege this morning to welcome you to the 8th CITA Technology Series seminar in 2013. And I also want to welcome you on behalf of today's event partners, Engineers Ireland, the Association of Consulting Engineers of Ireland, and the Institute of Structural Engineers. The theme for today is a segment of construction that I believe will grow in volume, exploiting the quality of the digital design models that are now becoming more common to enable and to deliver a level of sophistication of component and sub-assemblies, prefabrication, that will raise the overall quality and affordability of construction. So for that one very reason, I am very, very pleased to be at this morning's seminar. What I've said is not as far-fetched as it might seem. I mean, we all know this has already happened in automotives, it's happened in the aeronautics industry, it's happened very, very strongly in oil and gas, and it has happened in shipbuilding. There is absolutely no reason why the same revolution shouldn't happen in our own industry of construction. Today, speakers represent the leading edge of usage of digital models in prefabrication. The first speakers today are Denis McNeils and his managing director, Pat Egan of SIAC Butlers Steel. SIAC Butlers have a long history of adoption of digital control tools and use them to deliver the first application of what we now call lean manufacturing that I saw, and that was a way back at the beginning of the 90s. They have delivered the steelwork for the Aviva Stadium and for the Toyota plant in Derby, and there's no better testament, I believe, to their capability. So without further ado, just let me quickly run through the agenda and we'll get on with the speakers, which is the real theme today. And as you can see, after Pat and Dennis, Michael Keneally will follow, and I'll briefly introduce him, and then followed by Keith Rigg. We'll have questions and answers at that point before going back to see an application of Kingspan digitisation work that has been now applied to our technology pilot, and Bernard Fortman will introduce that.
Just I'd like to thank John and CITA and the event partners for asking us to come here to speak today. As John said, in SIAC Butlers Steel and in the steel industry in general, we have been using digital models for at least the last 20 years to produce our steel work. We can't work any other way. The steel work fits together in individual components into larger frames on site within millimeters, and in order to have the proper accuracies and efficiencies, once the material gets to site, we have to use digital modelling, and we've been using it for 20 years, so it's really bread and butter to us. And we're just hoping to get across today what benefit it is to us, and then perhaps you can take out to your own parts of the construction industry what benefit it could be to you in the long run. But as I said, we've been using it for a long time now, so we'll try and give our impression of how it works for us. That's just the Aviva Stadium there. John mentioned it, that's one of our landmark jobs. Just going to give a brief company history and profile of SIAC Butlers Steel, just so you know what we actually do. We're just going to list a few major projects that we've been involved in, and then Dennis will take over and he'll go through the detail on the digital fabrication in structural steel as applicable to SIAC Butlers Steel. SIAC Butlers company history and profile. The company was originally established as Butler Engineering in the 1960s. The company got into difficulty in 1995 when it was acquired by SIAC, the SIAC Construction Group, who still own the company today. It's a private company. We are operational in the UK. We are actually operational in the UK almost exclusively in recent times because of the situation in the construction industry in Ireland. So we have two UK companies, SIAC Tetbury Steel and Graham Wood Structural, which are the companies we work under in the UK. In our company we have expertise in all aspects of structural steel construction, small to medium and large building and civil engineering projects. So we do buildings and we do bridge work as well, so we have quite a bit of experience there. I suppose our exposure to both the Irish and the UK market has really, and we really do have experience of where BIM is coming into play. Although we don't see it that much coming into play, and Dennis is going to that in a bit more detail later, it does seem to be becoming a little bit more prevalent. Our company locations then we have locations in Dublin, Cork, Galway, Portarlington, which is our main fabrication plant, the largest fabrication plant in Ireland. We have an office in Belfast. In the United Kingdom, then we have a fabrication plant in Tetbury and in Lansing, which is down near the south coast. The departments we have, and just going through the departments, all our departments are linked back to our 3D fabrication model in one way or another, and they're a symbiotic relationship. They can't exist without each other, I suppose. So the main departments, similar to any construction company that we have, are tendering and procurement, design and detailing, whereby we produce the detailed drawings and the 3D model. We have fabrication and painting, which is the actual physical fabrication of the steel and the painting then. And then we have quantity surveying, which is the cost control, etc. of the project. And we have site installation, whereby is what you guys will mostly see is we go out to site and we put up the structure, and that's your final product. But all these processes are intrinsically linked via our use of a 3D modeling system. So everything is fed back into that system, and we can control individual pieces of steel and trace those back to our system via the 3D modeling. So it's very efficient for us. It means we know where anything is at any one time. We know what any size of a piece should be, size of a bolt should be, size of a hole should be at any one time. Just a brief look, we have a large fabrication hall and halls in Ireland and the UK. At peak we would have had 200 employees in Ireland and the UK, slightly less at the moment. I won't harp on, we have a lot of square metres of production facilities in both Ireland and the UK. We have total traceability of our material through our quality system. Again, that's linked to our 3D model. And Dennis will explain that in more detail. We would have at peak 1,000 tonnes a week of production capacity. Put that in perspective, the Aviva Stadium had 5,000 tonnes of steel in it. I'm not saying you'd fabricate it in five weeks, but you would do it along with a number of jobs. We have dedicated paint shops. We have dedicated domestic painting shops. Just some major projects that we have done over the years. That there is actually a screenshot showing the 3D model of the upper tier of the Aviva Stadium. So we can enter that model and find out any information we want about those pieces of steelwork. And that would be forwarded then to the next person on the line, for instance, the guy putting on the precast seating, etc. And he can extract information from that model. So since 1996, the company has been involved in the supply and installation of structural steel frames throughout Ireland and the UK, including, as I said, the Aviva Stadium. We're working on the Cork Gas Refinery, Blanchardstown Shopping Centre, Croke Park, Intel both in Ireland and in the Middle East, Pfizer Pharmaceuticals, Wyeth Pharmaceuticals, Microsoft Data Centre in Grange Castle, and various bridge projects, to name a few. But all these have been done using 3D modelling systems without exception. If we were to make the smallest piece of steel that you might fit up there and pick up in your hand, we'll input that into our 3D model along with the rest of the job. We don't do anything by hand, everything is linked that way. We have total traceability then. Now, Dennis is going to speak about digital fabrication. You get a little bit more, insofar in the time we have, I can explain a little bit more about the models, etc. Right, Dennis?
Yeah, thanks, Pat. I'll try and keep it relatively simple, but as Pat says, the steel industry as a whole has been effectively a BIM process for over 20 years. And the advantages to us were so apparent that very quickly the whole industry moved down the route of going to 3D software for the modelling and production of all the drawings. And there are numbers of companies around that do the software, but in Ireland up until recently it was primarily would have been two main companies, TrueCAD and Tekla, and now they're one company. So we've got more synergy happening, more production, more effectiveness coming out of the overall design process. If we take, come on, computer. We always have a computer glitch, don't we? No, I don't know. Yeah.
Yeah.
So, key to the way it works is in-house design and detailing. Because we have our 3D model, we then have full information flow feeding into production facilities and the estimating and, more importantly actually, is site. Because since we create the 3D model, and it's very heavy-end software, large computers required, they all have viewers, and those viewers we can send to site. So anybody, say an erector on site or the project foreman, if he isn't certain how something goes together, he can go onto the 3D model, rotate it in 3D space, find out how it goes, and check either a mark number or plate size or whatever, and feed back into there. But the key thing is everything we do, as I say, is 3D. The challenge moving forward is for us to get 3D information. If you take what's happening at the moment is an awful lot of practices, engineering practices, architectural practices, are now moving to the 3D world. And they're producing Revit models, or they're producing Navis models, or they're producing models in 3D. But what they then do is they convert them into 2D drawings, send them to us, where we convert them to a 3D drawing, and then we send the 3D model. We extract 2D drawings to send back to them to check. And each of those stages is a potential for error to creep in, or misinterpretation, or whatever. And there are now IFC classes which allow a Revit model to export out a file which we can import. And if we get that, we can then, it'll get rid of some of the errors that can creep in. But there is an education process that's required, and it is happening. We just hope it'll happen quicker. We've been doing it for 20 years. Hopefully this will move in the next 3 to 5 years. It'll be everywhere. In the UK, there's a very strong government push towards BIM, and they have a BIM strategy for 2016. From the steel industry, we're happy out, because we're BIM. We're level 2 BIM, so we don't have to worry about that. For the rest of the industry, there is a lot of fear about BIM, but there shouldn't be. It's not overly complicated. We're actually all working toward the BIM environment, but there's an education process, and I do feel it'll all fall into place. So, from our 3D BIM model, we then create, it feeds back into a main database, which is, on our case, is a Strumis database, or it could be a FabTrol database. It's a database. And that information then gives every plate size, every well size, so how much area of paint there is, what the weight of a piece is, so that from a site point of view they can say, well, that truss is going to weigh 45 tons, so I know how much I've got to, what size crane I need. Very difficult to do without a proper 3D model. And all of this feeds into our production facility. So when we produce the model, press a button, it runs off NC files, which are then fed into the equipment on the main line, which cut and mark every plate, which are all uniquely identified. And it produces fabrication drawings, which the fabricators will then use to pull everything together. And it produces dispatch lists, so that you know that you've got 22 tons on the trailer, and you know what pieces are on the trailer. So hopefully everything gets to site in one go. And finally, the CAM data. One of the things that is happening is that now the CAM data is going to the Strumis or FabTrol product, and it's feeding directly to the production lines. So you can actually say, I've got 45 of these end plates to make, but I only need 3 in this load of steel. And it'll send those 3 plates to the production line. It'll make 3 plates, and it'll actually tell the computer back saying, yes, I've now made 3 plates, and they've taken us 10 minutes a plate. That's the next stage as they're moving along. And we have every single bolt, weld, fillet, everything you can think of is in the model. So when you actually think of it, we're building a 3D real model. And it's not like you're just saying, well, it's close enough. Everything is to the millimeter, because everything that goes into the model comes out and is made and is erected. We get it wrong in the model, it doesn't fit. So, the IFC is moving forward. There are technological steps to be sorted out, shall we say. but it's 95% there. But it does mean that there's still a verification process. So even if I do get an IFC model in from an architect or an engineer, I'll still have to interrogate it against 2D drawings, because for various reasons, sometimes a member can be flipped through 180 degrees. So instead of the top flange being a top flange, it's a bottom flange, and it's now sticking through the floor. But if you have drawings, you can see these things very quickly. But if we then take a step back and we produce our 3D Xsteel or StruCAD model, we can export back out an IFC model. Now, our IFC model is a very tight subset of what a Revit model might be dealing with, because we're only dealing with section sizes and bolts and welds. We're not dealing with concrete or timber or insulation or whatever else that the main design team are dealing with. So the export is very rigidly defined and very clear, and that can be exported as an IFC model, which can then be imported into, say, directly into Revit or into Navisworks or into various other programs which allow for clash detection to be worked out. So the principle of that is we should actually be able to say, well, you've put the beam there, but we've got an MEP, a duct coming through, and your beam is clashing by 25 mil. And you find that out before it's made and erected, and somebody comes along and says, sorry lads, that duct has to go through there, move that beam 100 mil. It's very cheap and effective to do it in the model. The minute you do it on site, it's disruption and problematic. And sometimes it's very, very difficult to actually make the change geometrically. So what I have is I've got two models that I have with me. This one here is a warehouse garage that we did recently in the UK for the traffic police. Fortunately, it's in Wembley and we're not near it. But this is a very simple brace box building with long span beams. But I can go into the model and I can interrogate it and say, what is that piece? And down along the side it'll say it's on the first floor steel. This is the unique mark number, it's 2507. What steel grade it's made from, what size it is. If I come down here, I have the length, it's 16.509.75 mil long. And that will actually feed into the NC for cutting. And it gives me various other elements such as the gross area, which is how much paint do I need. So I can order in the right amount of paint. What the mass is, so the gross weight of that piece is 4.5 tons. That means on site they know the size of the crane. And that's simple for a straight beam, but if you've got a truss or a complex piece of geometry, it's actually adding up every single plate, weld, beam. So sometimes you'd be on a lift and you might be saying, well, the crane is good for 14 tons. Are you lifting 13.5 tons or 14.5 tons? And if it's 14.5 tons, you have to bring in a different crane. And that happens a lot. So from this, as you can see, you can interrogate the model, you can zoom in, you can isolate, so you're only seeing the piece that you're interested in. And the attributes are configurable. So if we want to add in an attribute to say the weld cert for the testing of this piece, we can apply it to the piece. If we want to say the material, so as you can get traceability back to where did the original piece of material come from, we can add it in. And all of this information can be handed back to the client at the end of the day. And if in 15 years' time or 10 years' time or 100 years' time somebody says, can I change that piece, or what was it made from, or there's a problem, the information is now available in a database form and is interrogatable, and people can make use of it. Another one that I have, which is just purely to show the difference or similarities between the two different pieces of software. This one is Tekla BIM site, which again is very similar in principle to what the Struma software, the BIM review software is. I keep on changing the name, I call it StruWalk. But it does the exact same process. Down the left-hand side, we can add models. So I can add in a DWG, I can add in another IFC model, and you can actually overlay them and see if there are clash detection, etc. Similarly, if I zoom in, this is one it's a 1,000-ton job that we've started 3 weeks ago. And this is what we've got modeled so far. In this case, the engineer provided us with an IFC model. We would not be where we are today if we did not get that. because even just the physical process of putting in however many hundreds of pieces are there and getting it sent back to the engineer so that they could verify it, so that we could get back, do the connection design and detailing it, finish it, and on Friday we start issuing 200 tons of steel on this job. So in 3 weeks we've gone from 0 to issuing 200 tons of steel. I think it's a record actually for us at the moment. But if I zoom in, just to give you an idea, you'll see every single bolt is on the piece, on the drawing. And if I right click on it, on my beam, in a similar way I have all the information about that piece. And there's a lot of information. So with this sort of technology, it gives us a lot of opportunities on how to improve coordination and collaboration on jobs. And to be honest, I think if anything, this job has proven the benefits of going down a 3D model sharing approach, because we're now going to be sending back an IFC model so that they can do a clash check. It will also feed into the, say, the cladding people, the secondary steelwork for handrails, balustrades, stairs, and hopefully the MEP people, MEW, so that we know whether or not we have sufficient space for electrical, mechanical and process. So I suppose that's just a quick summary, and I emphasize quick, as to how we use BIM.
I suppose just to finish off what Dennis was saying there, there's benefits to us, but we couldn't work without it.
No.
There's benefits for, you know, for cost, there's benefits for schedule, and benefits for quality, and we wouldn't be able to work the way we do without it. So there's no reason why it can't be applied across the you know. So thanks Dennis for that. Dennis is our technical director, by the way. He also sits on the British, the BCSA, which is the British Steelwork Association BIM committee as well, so he knows quite a bit about it. So thanks for that, Dennis.
Okay.
Thank you.
Thank you.